We're going to solve each of these inequalities and graph the solution set. Inequalities with variables on both sides are very, very similar to equations with variables on both sides. You just have to remember x's on one side, numbers on the other. Your answer always will include an inequality symbol, and a lot of times we will graph them. For problem number 1, we have 2x plus 3x minus 4 is greater than 3 times the sum of x and 8 minus 2. When I look at the left side, I have a lot going on here. I have 3 terms. So I'm going to look and see if I have any like terms. 2x and 3x are like terms, so I'm going to combine them together. That's going to give me 5x. And just bring down the minus 4 is greater than, I see parentheses, so I'm going to distribute, which means multiply the number on the outside by everything inside the parentheses. So I'm going to get 3x plus 24. I'm going to bring down the minus 2. The left side is as simplified as it can get or cleaned up. On the right side, I have 24 and a minus 2. Those are like terms, so we're going to combine those together next. So we bring down the 5x minus 4 is greater than 3x. 24 minus 2 is 22. Now I have to make a decision. Do I want x's on the left or the right? I would just bring the x's on the left. It makes it easier sometimes for y'all to graph. So if I look at this, I'm going to move the 3x to the left side. It's positive 3x, so I'm going to subtract it. So we get 2x minus 4 is greater than 22. I now have to put my numbers on the right side. I'm going to add 4 to both sides. I'm going to get 2x is greater than 26 and divide both sides by 2. X is greater than 13. That means any number bigger than 13 is part of my solution set or will make my original inequality a true statement. If I wanted to graph this, I would draw my number line. 13 goes in the middle. A number bigger than 13 is 14. A number smaller is 12. My circle goes on 13. It's going to be unshaded because x is just greater than, so I can't actually equal it. X is greater or bigger. 14 is bigger than 13, so I know I'm going to go to the right. For problem number 2, I don't have quite as much going on. I do have x's on both sides. So again, I have to decide, do I want my x's on the left or the right? I would just always put them on the left. I'm going to subtract 2x from both sides. I'm going to get 3 minus 2 is 1x. Bring down the plus 8. Bring down my inequality symbol. Bring down the minus 2. I need my numbers on the right side, so I'm going to subtract 8 from both sides. X is less than or equal to negative 10. X is by itself. That means that negative 10 or any number smaller than negative 10 would be part of my solution set. I could plug those numbers in and make this inequality a true statement. I can graph it. So negative 10 goes in the middle, negative 9 is bigger, negative 11 is smaller. I have a circle at negative 10 because that's where I found my answer. It's going to be shaded because x can equal it this time. So again, another way to remember it is I use more ink here. So I'm going to use more ink here. Smaller, negative 11 is smaller than negative 10, so I'm going to go towards the left side. For problem 3, I got x's on both sides. The first thing I notice is, oh, I've got this fraction. Fractions sometimes can be a little intimidating, especially when they're big fractions. So to undo a fraction, we know that's division. We're going to multiply both sides by 3. Like, okay, the 3's become 1. I'm going to be left with 2x plus 6 is less than 12x. And then so any variables on one side, numbers on the other, it doesn't matter which side you put them on. I would always just put them on the left. If you're going to do that, we're going to subtract 12x from both sides. 2x minus 12x is negative 10x. I bring down the plus 6 is less than. We know 12x minus 12x is 0, so I'm going to write that in there for a second. Now if variables on the left, numbers are going to be on the right. I'm going to subtract 6 from both sides. I'm going to get negative 10x is less than negative 6. And then I'm going to divide both sides by negative 10. When I divide by a negative number, I have to flip my inequality symbol. So x is going to be greater. Negative divided by negative is positive, and 6/10 will simplify to 3/5. If I want to graph it, I can. There's a few different ways that you could go about graphing this. 3/5 are going to be in the middle. You can either go up by a fraction. So the fraction bigger would be 4/5. The fraction smaller would be 2/5. You could also just have put this as 0 and made this one 1, because we know 3/5 is between 0 and 1. So there's lots of ways you could do your number line. My circle is going to be at 3/5. I'm not going to shade it in because x is just greater. Because x is greater, 4/5 is bigger or greater than 3/5. My arrow is going to go towards the right. For this inequality, I have 2/3 x plus 6 is greater than or equal to negative 1/3 x plus 2. See the fractions? They are coefficients of the x, so I'm not going to go multiply yet. I'm going to get the x on one side, numbers on the other. So I like my x's to be on the left. I'm going to add 1/3 x. So 2/3 x plus 1/3 x gives me 3/3, which is just 1. So we're just going to get x plus 6 is greater than or equal to 2. And I'm like, phew, the fractions are gone. I want numbers on the right, so I'm going to subtract 6x. I'm going to get x is greater than or equal to negative 4. And then I can go ahead and graph. So remember, any number greater than, bigger, or equal to negative 4 would be part of my solution set. Negative 3 is bigger than negative 4. Negative 5 is smaller than negative 4. My circle is going to go at negative 4. I'm going to shade it in because I have the equal to. Because x is greater, I'm going to go to the right.